All right, measures of variation. So lovely formulas. Look at these babies. Ooh, strikes fear into the hearts of people. Fortunately, you remember when we did the one-bar stats that there was a line item that said S equals. It said SX, but it said S. That also says S. I wonder if they're the same S. Spoiler, they are. So we're good. I'll show you how to do it by hand the one time, so you get a feel for it. But then just know that you don't have to do it by hand. On the calculator. And if you weren't sold on the benefits of the calculator before page 6, you'll be sold after this one, I promise you. So anyway, the formula works inside out. Order of operations work inside out. So whatever's in the parentheses happens first. The pen does. Please excuse my dear Aunt Sally's the way I learned it. I don't know if they have like 21st century acronyms. It seems like they always want to reinvent the wheel. All right, parentheses, exponents, multiplication, division, addition, subtraction. So we are dealing with parentheses first. So let's take care of x minus x bar. All right, so I'm going to create a column of x minus x bar, which would require me to know what x bar is. I got 1, 2, 3, 4, 5, 6, 7 values there. 14, 17, 23, 28. So 28 over 7 is 4. So what I'm doing is I'm going to take each x value and subtract from it 4. Let me get a little line here. So it's going to be negative 2, negative 1, 2, negative 1, 2, 4, negative 4. Let me just double check. Kind of zoned out there for a sec. Yeah, I think it's good. Plus. Next up would be exponents. I'm going to take care of the binomial squared. Now the reason why we're doing a binomial squared is because when we're looking for deviation, standard deviation is what we're going to end up looking for, but forget about standard. Just think about the word deviation. How far something is away from something else. Okay? If I'm standing behind you, in front of you, next to you, whatever, if somebody asks me how far I am away from you, I'm not going to say I'm negative 2 feet. I'm going to say I'm 2 feet away. Okay? They're not really overly concerned with the direction. Odds are they probably know what the direction is if they're there to ask you, unless they're on the phone or something. So we need only positive values. So the question becomes, well, why square? Why not just drop the negative? Well, there's 2 reasons. One, we're going to square it here and then take the square root later on, so they're going to offset each other anyway. So it'll end up being an equivalent relation. So that's a mathematical justification of why we're allowed to do it. If you do something and then later on undo it, it's like it never happened, right? So it's like adding 1 to later on subtract 1. If it makes it convenient early on, then cool, do it. But the real reason is because there is a whole world of inferential statistics, the 3rd unit of the course, that's built around the standard deviation. Okay? So that number corresponds to certain properties that exist in nature. The other thing called the mean deviation, mean absolute deviation, the one where you would just basically do the same thing we're about to do but drop the negatives, there aren't as many powerful relationships out there, right? So it's kind of like an ends justify the means kind of situation. But what are we doing? We're just squaring everything. Raise everything to the 2nd power, which means you're dropping all the negatives, because when you square a negative, it becomes positive, and then every number gets raised itself to the power of 2. All right. So shrink this down. I always overdo it with that. So now I need the sum, because multiplication is not relevant here. Neither is division yet, until we take care of the summation component. Right? Because in a fraction, fractions themselves form a certain type of grouping. So that's kind of like a different sort of parentheses. But basically, I'm going to take the sum of all my x minus x bar squareds, which is just basically telling me to add this column. 32, 36, 37, 41, 42, 46. 10, 14, 30, I think so. Then we're going to divide by n minus 1. Yeah, I still have that same ringtone myself. It's catchy enough that I haven't felt the need to change it. Some of the older phones, like the Nokia's back in the day and things like that, the rings were just so obnoxious. It's like I gotta get out of here. It's n minus 1. Right, so we're dividing by n minus 1, which is kind of a weird thing to do because when we find the mean, we divide by the number of values in the data set, but for some reason with standard deviation, we divide by 1 less than the number of values in the data set. We do that because of a concept that I hate to do this, but all will be revealed in November. It's a concept called degrees of freedom that justifies why this is something that we can do. There's no way I can explain it now because we wouldn't have the vocabulary yet, but we will, and hopefully you'll still care then. I don't know, it's hit or miss. But it's 7 minus 1. And what that's going to give us is s squared. So 46 over 6, 23 over 3. It's a decimal. So, oh, it's a repeating jab. All right, so I'll do. Yeah, I'll just leave it as I'll just leave it as a fraction then. It's just 23 over 3. It's the reduced form, because that's ultimately, or essentially, not what we're looking for. I don't know what the right word is there. Sample standard deviation is the square root of the s squared. So s would be equal to the square root of 23 over 3. So let's work with the more exact s squared value. Take the square root of that. You can put it in as division here, 23 divided by 3. It's just if you over round it in an intermediate step, that's going to introduce possibly an unacceptable amount of variation in your final answer. Unacceptable in that it might cost you credit on a test, or kill somebody. That's the other thing. 2.769. I just look at it like it's an easier explanation in trig than it is in stats. But if you're off with certain medications by a unit, even the smallest of units, depending on what the medication is, you could do some serious damage. But in trig, I think it's a little easier to explain because if you have a start point and an end point, and your goal is to travel along that path, and let's say that path is precisely 0 degrees, right? ran the calculations and you determined that it's supposed to be 0 degrees precisely. It's exactly 0 degrees. You're good. Not a problem. But let's say you came up with 0.01 degrees. So it's a very slight deviation. In the short term, that's a broken piece of chalk, which is why I don't use it. In the short term, you're not looking at much deviation between where you are and where you're supposed to be. In the long term, you have a very significant deviation between where you are and where you're supposed to be. All right, so it all depends on the situation, but a slight miscalculation in angle could lead in the long run to a major miscalculation. All right, so when you thought you were aiming your plane towards New York and you end up in Buffalo or Detroit or Toronto or something like that, you're probably not a happy camper. Right. So that's, you know, kind of a suspend your disbelief kind of situation, because there are things like communications. You know, the control tower radios in and says, hey, listen, for whatever reason, you're not coming here anymore, and we don't know why. You may want to change the direction of your plane because you're not aiming for us anymore. You know, so, you know, not the best example, but my children's hospital example doesn't always go over well. It was a good one. It involved missiles and military target and children's hospital, which isn't too far away, and it was very sad, very sad. The children didn't make it. So find the sample variance and sample standard deviation for the following data set. All right, so this is asking for both. Now, you see the formula that we used here is only for a raw set of data. There's another formula if you have a frequency table. That formula has an additional component, which means that the calculations that we would be doing by hand would have an additional column. So, but we're not interested in doing that. We're interested in using our calculator. So, stat, edit. Clear what you got in there. Good practice clearing out data. Build up a little muscle memory. Go to L2, hit clear, hit enter. Go to L1, hit clear, hit enter. Eventually it becomes something you could take for granted, you know, like before you know it, you'll be doing it without thinking. Type in your data. Right arrow to get to L2. All right, so we have our information there. Quit out. So I'm doing the exact same process for a third time. So hopefully if you weren't paying attention the first two times, you're paying attention now. And I'm not even judging. It's Saturday morning. I don't even know if I'd be paying attention. I think my recurring thought would be, I'll pick it up later on the video. Like I'm too tired right now. I don't know. Something. So stat calc 1, L1, L2, calculate. For simple lists of data, the ones that don't involve frequencies, I tend to do it by hand, unless the numbers are like funky decimals, just because I don't like messing with this menu. Because if it's not a frequency list, then this shouldn't be L2, it should be 0. It should be blank or a 1. But most of the time you're going to be using it for frequency tables anyway. So I'm going to take this display, pop it in here, And you can see the mean here is nasty. We needed the mean in order to complete the first column, which means the first column is going to be nasty if we did it by hand. We had to square the first column to get the second column, which means the second column would be nasty, the third column would be nasty, everything would be nasty. Okay, so let me check my data. Checking my data. My data looks good. You got mine? All right, Team Can. Yeah, so it looks good. So hit stat edit and check your data, make sure it's correct. Anybody ever work in data entry? A little bit sucks, right? Yeah, it's like brutal. It's like this, but with like names and stuff too. Ugh. I know somebody wasn't taking their data entry job seriously back in 1994 because I still get mail that says Theodore Can instead of Theodore Can. That's not how it's spelled, but whatever. Did we figure it out? That's good. Okay, stat. Oh, frequency list. L2, second 2. And then calculate is going to work.
That's it, right?
Yeah, that's perfectly. Yeah. All right, so we have SX right here, but they asked us for something else. They said find the sample variance and the sample standard deviation. All right, so sample variance. We'll get to that in a second. Sample standard deviation. We're looking at approximately 16.231. All right. Now, sample variance, different story. There, to the best of my knowledge, and I'm usually pretty good about these things, there is no button on your calculator that is sample variance. There's a variance key, I believe, but I believe it's population. It just says variance. It may not even, I don't know. But we can compute it pretty easily because the sample variance is S squared. So I just have to take my standard deviation and raise it to the power of 2. All right, so that's great because I have everything I need. The issue is I don't want to type in 16.231 and square that. I want the entire decimal because otherwise I have a New York-Detroit situation. All right, possibly unacceptable deviation between my answer and what the answer should be. All right, so how do we do that? We either make note of the entire decimal, retype it in, and then square it, or there is a set of shortcut keys that I'll show you. So this key right here, the vars key, it would be so nice if that stood for variance, but it stands for variables. So something else to get used to. On I might have mentioned this, but if I didn't, I apologize. On the first unit test, definitely, and usually the second one also, I allow a 3" by 5" index card with handwritten notes. For this class specifically, most people interpret that as a 3" by 5" index card of handwritten steps on how to use the calculator. So don't mail it in when I go over something. If you're looking at it, be like, I'm never going to remember that. Forget it. I'm not even going to bother. Write down the steps because that can make its way to your index cards, which then is your resource on the test. So we went to the vars key. It brought us to this menu. So every variable related to the calculator, so every symbol that is related to something that could be calculated is in here somewhere. Window, if you came from an algebra course, a pre-calc, something like that. Anything that's in the window menu, like X-min, X-max, that's all listed there. Anything that's in the zoom menu, like zoom fit, zoom stat. Statistics, obviously, is the one that we want. So we're going to go to option 5. So hit the number 5, or just go down to that option and hit enter. I'll just hit 5. And you see you have all of this stuff here. It's great because the thing I need is in the first menu. So option 3, SX. So hit enter, or the number 3, and then square it. It is right next to the comma. Okay, so 263.441. It's entirely possible. I didn't fact check this, but it's entirely possible that if I take 16.231, the rounded form, square it, and then round that I'll get the same rounded answer that I got here. Perfectly fine. But if you're thinking in terms of exactitude, then this approach is better because what we use in a computer or in a calculator and what we write down on paper are not always the same thing. So if you're doing a statistical analysis in your spreadsheets, you'd be working with the most exact values, but in your write-up, you would say around 263, approximately 263, verbiage like that, because the people reading it aren't going to be reading it with a calculator in their hand. They're just going to want to get the gist of what you're talking about. All right. So, but you should have access to the most exact answers. All right. So, just going back, what we had to do was 1 var stats to get this, to get the SX to begin with. All right. So, 1 var stats on L1, L2. I moved it too far to the right. Then we did vars, statistics, option 3. That brought the SX to the screen, which we then squared. All right, so that's the exact approach. And the good news is, it isn't just for this concept. If you want to recall something from earlier, like, let's say you cleared your screen and you want to have access to the mean. Again, vars, statistics, there's my mean, option 2. If I need to do something like, I don't know, maybe the interquartile range, vars, statistics, you can start looking around for those items that we had before, like the Qs, like we have max and mins and things like that. Find the quartiles if they exist anywhere. Q1 is Q3, it's under points, but it's going to be in this menu here, so just scroll around and familiarize yourself with it. So it'd be option 9 minus vars option 7. So I could get my interquartile range. You know, when they're clean numbers, it's easy to do it just from the printout. But if they're hideous numbers, then maybe you don't want to type in the decimals, so you can work out of this menu. It's not. It's more of a luxury than anything else. If you're comfortable with it and you like doing it this way, then go for it. If you don't, if you look at it as a necessary evil and you just want to do the bare minimum, that's fine. I totally understand it, because again, I started this whole class off by saying the calculator is not intuitive. So if you're still thinking that, you're correct, because if you have to write down steps to help you remember to do stuff, then that thing that you're trying to remember to do is not intuitive. Okay? You should be able to go to it, turn it on, and be able to feel your way through it like an iPhone. All right. So anyway, let's take 5, and then we will continue on with position, and then I'll show you how to write a program, and then